everyone, Wayne from the CERN Earth and Space Center here. In today's video we're going to be talking about the summer solstice, or the longest day of the year so far. It's rapidly approaching. It'll be on June 20th of 2021, so just right around the corner here. And we're going to talk a little bit about the path that the sun takes through the sky. So let's jump into our sky simulator and take a closer look. So here we are, standing in front of the CERN Earth and Space Center. We have our date set for June 20th. It'll be the day of the summer solstice. And our time is set for noon. So we're looking at our daytime skies right now instead of our usual nighttime. And this is near the point where the sun will be at its highest point for the year, high up in the sky. And we can bring up our ecliptic line, which is the path that the sun, the moon, and the planets all take through the sky. And we can see how it stretches across the sky. This is the path that the sun will take. And the summer solstice is the longest day of the year. We have the most daytime skies. And we can see that is because it does stretch so high across the sky. It takes much longer to go all the way across the sky. Now, if we change our date to the winter solstice, which will be December 21st, we'll just change that and we'll see how much lower the sun gets in the sky in December. So this is the shortest day of the year, and we can see that the ecliptic passes very low, nearer to the horizon, so the day is much shorter. And then just in between those, we have the spring and autumn equinoxes, and those when we have equal times day and night. And if we were to plot out the path of the sun over the course of a year, it makes a very interesting shape, and I can show you what that looks like. So let's take a look at what sort of shape that would make in the sky. So we'll load up our clip, we'll watch the sun, which we can see here, as it travels its path through the sky. And so we'll start right here, and then we'll see as we go through the year, it starts at its lowest point near the winter solstice, goes up through the sky to its highest point, which will be our summer solstice, just coming up here, and then travels back down to its lowest point near the winter solstice. And then that makes up a shape called an analemma, and it's sort of this figure 8 shape that we can see in the sky. It's a very interesting shape. You can map it out yourself if you wanted to draw yourself a little map and plot out the position of the sun on each day at the same time every day. Then you should be able to get that shape in the sky as well. It's a very interesting little project to work on. But that's just a little bit of background on the summer and winter solstices as well as our equinoxes. And all of this has to do because of the tilt of the Earth from the sun. Now, we are in the summertime, so the northern hemisphere here is tilted towards the sun, which gives it that higher up in the sky. And then as we go around the sun, the northern hemisphere will be tilted away, which makes it appear lower in our skies, giving us those shorter daytimes. That all has to do with because the axis of the Earth is tilted at around 23 to 24 degrees away from the sun. Well, thank you, everyone. I hope you enjoyed that video. Again, my name is Wayne from the CERN Earth and Space Center at Triton College in River Grove. I hope you enjoyed our look at the summer solstice and the analemma of the sun. Now, remember, the important thing for you to do is to get out there and take a look at your nighttime or daytime skies.